Hey chemistry, how's it going? Are we like 3, 4 weeks into distance learning now? Yep, we are. But you know what, you guys? Nobody caused this. This is just something that's going on, and we're all doing our best to get going and continue in distance learning. So, students, you guys are doing great. Teachers are very, very busy converting all their assignments to be digital, and thank you guys so much for your patience with all your teachers. It's been helpful on our side of things. 11.4 here, video lesson. You may have noticed that we skipped 11.3. Just one question in your Google Classroom on a concept that we cover in 11.3, which is called a limiting reactant. And that we decided to skip the math on that one, but I do have one question for you to answer on the idea of a limiting reactant. So answer that one, and then we're moving right along to 11.4. We cover percent yield in 11.4. It's quite a simple calculation. It's just simply taking your actual yield and dividing by your theoretical yield. Of course, because it's a percent, we multiply by 100 at the end to convert to percent form. However, some of the math in this section requires you to find these different components before you can divide them, multiply by 100. The difference between actual and theoretical yield is that in an actual yield, that comes from an experiment. So it's what you actually got when you performed an experiment. But a theoretical yield we get from doing the math. So it's like, in theory, how much should you have gotten? Actual yield being actually what you got. So those two words, I hope, make a little bit more sense after highlighting where you do the math and where you actually do an experiment. So I have an example for you. And some of your problems are just going to be giving you the number of grams for theoretical and actual, and then asking you simply to calculate the percent yield. So if this is your second time through on this video, push pause, copy this down, and try it out. And here's the answer. Our equation tells us to take actual and divide by theoretical, multiply by 100. Our actual was 20, our theoretical was 25, multiply by 100, and you get an 80% yield. Notice in the equation, in the example so far, we've had grams, and the grams cancel out, and therefore we just have a percent as our final answer. No moles should show up in the calculation of a percent yield. If you're given moles in an equation, then you need to convert first to grams and then put it into this fraction to calculate percent yield. Which brings us to our next example, in which we will be given grams, and we'll have to use stoichiometry to convert from grams of a reactant to grams of a product. And that involves some math. So we're going to find our theoretical yield by way of stoichiometry. So example 2, go ahead and upon heating, calcium carbonate decomposes to calcium oxide and carbon dioxide. Go ahead and come up with a balanced equation, because that's the first thing that you need to do. So if this is your second time through the video, push pause and work this out. And there you have the balanced equation. You may have noticed that as you're balancing it, there's 2 calciums on each side, 1 carbon on each side, and 3 oxygens total on each side. 2 plus 1 is 3. So we didn't need any coefficients to balance this one. It simply broke apart in a 1:1:1 mole ratio. Go ahead and work out B. I'm going to give you that 235 grams of calcium carbonate was heated. So we need to determine the theoretical yield of CO2. So remember, theoretical yield is going to involve some math, which we'll use stoichiometry to figure out. So let's think through this. 235 grams on the top of calcium carbonate. That's right, grams of calcium carbonate on the bottom. So you're going to start out your stoichiometry problem that way. If it's your second time through the video, go ahead and press pause and determine the theoretical yield, which of course will be in grams, just like our example up here. And here's how I got the theoretical yield of carbon dioxide. 235 was the number given, so start there. make them units match. Grams per mole, we can calculate a molar mass using our periodic table. And moles on top, moles on the bottom. Here we get to the molar ratio that we studied in the first section of chapter 11. This is that border that we cross when we're in Moleville to get from grams of substance A to grams of substance B. So, or substance or particles in our mole map from the mole map section, which was in chapter 2. So converting here from moles of CO2, moles on top, moles on the bottom, and we have a molar mass of CO2 to finish up this problem. 103 grams of CO2 is where we end up here. The next part is to calculate the percent yield of CO2 if we have 97.5 grams of CO2 collected. Now that word collected is a key word for actual yield because it's what we actually got in an experiment. So that's going to be the number that goes on top in our fraction. We just calculated the theoretical yield. So you're going to use your formula to finish this problem out. Push pause, try it out. So for the final answer here, I just fit it in the corner of my piece of paper here. 97.5 divided by the answer we got for part B, which was 103 grams. Grams cancel, so our answer is simply in percent. Oh, you know what? I forgot to multiply by 100 to show my work here to get it in percent form. So don't forget that step. But a couple things to point out here. Notice that whenever we're throwing things in a percent yield formula, it's in grams. So don't try to throw moles in here. Don't try to throw grams of one substance divided by grams of another substance. That doesn't work. It has to match in what kind of substance or molecule or formula unit we're looking at. A couple other things when you do your stoichiometry. As always, I expect proper form here. Grams on top, grams on the bottom. Make sure you put your molecule or formula unit name, and make sure that as you're going along in stoichiometry, we either change the unit or we change the molecule name. But we never change both. So remember from section 2, you're only ever changing one thing at a time. In this fraction, we kept the moles the same, but we changed the molecule name. In this fraction, we changed the unit from moles to grams, but we kept the molecule name the same. So those hints still follow true all throughout this section as you're calculating percent yield. So go ahead and get that homework done. We'll review some next week and then take our test on chapter 11 next week. Great job, everybody. You really are doing great. Keep up the good work.